Look at it. 850 years old, still standing, still leaning. The Leaning Tower of Pisa is the most recognized building in the world that was never supposed to look the way it does. Every other famous structure in this series was built to a plan and came out as intended, taller, more luminous, more structurally ambitious than what came before. The Tower of Pisa was built to stand straight. It started sinking before the third floor was finished, and the men who built it kept going anyway. That decision, to continue construction on a tower they knew was moving, is the reason it is still standing today. Not despite the lean, because of it. There is one structural fact about the Leaning Tower of Pisa that most people who have visited it do not know. The tower did not lean continuously from the moment it started sinking. It leaned and then it stopped. Then it leaned more and stopped again. The construction was interrupted twice, once for nearly a century, and those interruptions, which happened for reasons that had nothing to do with the tower itself, accidentally gave the soil beneath the foundation time to consolidate under the uneven load. Each pause allowed the ground to partially stabilize before the next phase of construction added more weight. Without those pauses, the tower almost certainly would have fallen during construction. The interruptions saved it, and no one planned them. We get to why. But first, the ground. Because everything about this tower begins and ends with what is underneath it. Pisa, Italy, 1173. The city is wealthy, confident, and at the height of its maritime power. Pisan merchants trade across the Mediterranean. Pisan ships have defeated the Saracens and the Genoese. The Campo dei Miracoli, the Field of Miracles, is already taking shape. The cathedral, begun in 1063, is nearly complete. The baptistry is under construction. And now the chapter has decided to build a campanile, a bell tower, to stand at the eastern end of the cathedral complex and complete one of the grandest ecclesiastical ensembles in Italy. The site is the western edge of the Arno alluvial plain. The soil here is not the competent ground you find further inland. It is alluvial deposit, layers of clay, sand and silt laid down by the Arno and its tributaries over thousands of years, still shifting, still compressing under load, saturated with groundwater that sits close to the surface for much of the year. This is not good ground for a tall, heavy tower. Anyone who had built in Pisa before 1173 knew this. The soil conditions in this part of the city were not a secret. The cathedral itself, broader and lower, had been designed to distribute its weight across a larger footprint, precisely because the ground could not be trusted to support concentrated loads without settling. The tower was designed differently. It is circular, a hollow cylinder of marble rising in 8 stories of colonnaded galleries, approximately 56 meters tall when complete, with walls roughly 8 meters thick at the base and a total weight of approximately 14,500 tons. All of that weight concentrates on a ring foundation roughly 15 meters in diameter. The pressure on the soil beneath that ring when the tower is complete is substantial. On firm ground, manageable. On saturated Pisan alluvium, a problem that was always waiting to happen. Construction began in August 1173. The master builder, the historical record is complicated here with Bonanno Pisano credited in early sources and Diotisalvi suggested by later scholarship, and the true attributions still debated, designed a shallow ring foundation roughly 3 meters deep. 3 meters on ground where the water table rises seasonally to within a meter of the surface. On ground that is, in the technical sense, not fully consolidated even before a single stone is laid. Pisa, late summer, 1173. The marble for the tower comes from quarries in the Apuan Alps, the sharp white peaks visible from the city on clear days, transported by river and ox cart to the Campo. The marble is white Carrara marble, the same stone Michelangelo will use for his sculptures 3 centuries later. Dense, heavy, luminous in afternoon light. The foundation trench smells of wet clay and groundwater. The men digging it work with the particular care of builders who know that the soil they are cutting into does not behave like stone. The first and second stories rise. The marble drums are set, the columns of the gallery stories placed, the mortar joints packed carefully. By the time construction reaches the third story, sometime around 1178, the tower has been standing for approximately 5 years. And then the south side starts to sink. Not dramatically, not visibly at first, not to anyone standing at a distance. What the builders notice is in the levelling, the careful measurements taken with plumb lines and water levels that any competent building crew of the period would have used to verify that each course of stone was being laid horizontally. The measurements show that the south side of the foundation is lower than the north. By how much in 1178 is not recorded, but enough that the builders know. The ground is moving. Here is what they are facing. The soil beneath the south side of the foundation is softer than the soil beneath the north side. Not by much. This is not a dramatic geological difference, not a fault or a void, but enough that under the increasing weight of the growing tower, the south side is compressing faster. The foundation is tilting. The tower above it is beginning to lean. They have 3 options. They can stop and demolish what they have built. They can try to correct the lean by adjusting the stonework above it, or they can keep building and hope the ground stabilizes. The historical record does not tell us what decision was made in a single meeting or moment. What the record shows is what happened. Construction stopped. Not immediately. There are signs of continued work through the third story. But by around 1178, the active building campaign ends. The tower stands at roughly the height of the third story, incomplete, already leaning, and apparently abandoned. And then, Pisa goes to war. The political and military conflicts that occupy Pisa through the late 12th and most of the 13th century, conflicts with Genoa, with Lucca, with Florence, with the shifting alliances of Italian city-state politics, consume the city's resources and attention for nearly 100 years. The tower stands on the Campo dei Miracoli, incomplete and leaning, while the city fights for its survival and its commercial position in the Mediterranean. This is the pause that saves the tower. Not planned, not engineered, not the result of any decision about the building itself. A century of war happened to interrupt a construction project at exactly the moment when interruption was structurally necessary. Under the uneven weight of the incomplete tower, heavier on the south side because the masonry there had settled lower, the soil beneath the foundation was slowly consolidating. Clay under sustained load does not compress immediately. It compresses over years, over decades, as water is gradually squeezed out of the pore spaces between the clay particles. The process is called consolidation, and it produces eventually a denser, more load-bearing soil than existed before the load was applied. The south side of the Pisan soil, under the weight of 3 stories of Carrara marble for 100 years, was consolidating, slowly becoming more capable of bearing the weight above it. When construction resumed around 1272, the ground beneath the south side was measurably more stable than it had been when the first campaign ended. This is not speculation. Geotechnical analysis of the soil beneath the tower, conducted in the 20th century as part of the stabilization project, confirmed that the clay layers beneath the south foundation show evidence of consolidation consistent with prolonged loading over many decades. The soil had been changed by the weight of the unfinished tower in ways that made it safer to continue building than it would have been to build continuously from the start. The first pause had done something invisible and essential. The tower was ready to grow again. Construction resumed in 1272 under Giovanni di Simone. By this point, the lean was visible and measurable. The south side was lower by enough that anyone walking around the base of the tower could see it. The builders did not pretend otherwise. They addressed it directly, in the only way available to them. They built the next stories slightly curved, adding slightly more marble to the north side of each course than the south, so that the axis of the upper tower bent back toward vertical. You can see this today. The tower does not lean as a straight line. If you look carefully at the profile, it has a subtle banana curve, the lower stories leaning south, the upper stories correcting back. The correction did not eliminate the lean. It reduced it slightly and, more importantly, it shifted the center of gravity of the upper tower back toward the center of the foundation, reducing the tipping moment that would eventually threaten to push the whole structure over. This is the same structural intelligence that appears in every building in this series. Not perfection, observation, correction, continuation. The builders of 1272 did not solve the problem. They managed it. They built compensations into the stone that kept the structure viable without stopping the project. Here is the detail about the construction process that most accounts of the tower omit. The marble for the tower had to be lifted story by story by men using hand-operated cranes and rope and pulley systems mounted on the scaffold at each level. As the tower leaned, the geometry of this lifting changed. A load lifted vertically on the south side of a leaning tower does not hang plumb with the scaffold. It hangs away from the wall, requiring the workers on the south face to manage an outward swing on every lift that workers on the north face did not experience. At the heights involved, the upper stories are more than 40 meters above ground. An outward swing of a marble block on the end of a rope is not a minor inconvenience. It is a serious physical risk. The workers who set the marble on the south side of the upper stories were managing loads that wanted to swing away from them every time they lifted, on scaffolding that was itself leaning outward over empty air. The building accounts from the second campaign have not survived in detail. What has survived is the stone, set precisely, mortared carefully. The courses level within each story despite the overall lean of the structure. Men working at a physical disadvantage because of the lean produced work of the same quality as men working on a vertical surface. This is not noted anywhere in the historical record as remarkable. It was the job. They did it. Construction stopped again around 1284, this time because of the naval Battle of Meloria, where the Genoese destroyed the Pisan fleet and effectively ended Pisa's maritime dominance. The city entered a long economic decline. The tower stood again, incomplete. 7 stories finished, the belfry not yet built, for nearly another century. The second pause consolidated the soil further. When the belfry was finally added in the late 14th century, completing the tower, the foundation had been under load in 2 separate phases, totaling several decades with 2 long pauses for consolidation in between. The structure was as stable as it was ever going to be on Pisan soil, which was not very stable, but stable enough. The tower was complete by approximately 1372, nearly 2 centuries after the first stone was laid. Now, the lean at completion. At the end of the 14th century, the south side of the foundation was lower than the north by a significant and measurable amount. The tower leaned. Everyone could see it. And as the centuries passed, it continued to lean. Slowly, incrementally, but continuously. By the 20th century, the overhang at the top was approximately 4.5 meters from where it would have been if the tower stood vertical. The tipping moment, the rotational force trying to push the tower further, was increasing every year. By 1990, engineers had calculated that the tower was approaching a critical threshold. Not imminent collapse, the margins were still significant, but a trajectory that, without intervention, would eventually reach failure. The tower was closed to visitors. An international team of engineers spent the next decade developing and executing one of the most delicate structural interventions in history. The solution they chose was soil extraction. On the north side of the foundation, the high side, they drilled angled boreholes into the clay beneath the foundation and slowly, carefully extracted small amounts of soil. As the north side lost support, the tower settled fractionally northward, reducing the lean, not eliminating it, reducing it. The target was not vertical. The target was to return the tower to the angle it had in 1838, before modern monitoring began. A lean considered to be safely within the structural margins. The extraction was conducted over years in small increments with continuous monitoring of the tower's response. It is one of the most precise geotechnical operations ever performed on a historic structure. By 2001, the lean had been reduced by approximately 44 centimeters, from 5.5 degrees to 3.99 degrees. The tipping moment was reduced to a level that engineers calculated would keep the tower stable for at least another 3 centuries. The tower is still leaning. It was designed to stand straight, and it never will. But it will stand. Stand at the base of the tower today and run your hand along the marble at ground level. Carrara marble cut from the Apuan Alps in the 12th century. Still white, still smooth, still slightly cool even in the Italian summer heat. Look up along the south face, the low side, the side that has been sinking since 1178. The lean is immediately physical here. The tower above you is not over you. It is past you, angled away from vertical, 56 meters of marble, describing a trajectory that ends nowhere near where it started. The Campo dei Miracoli smells of cut grass and warm stone, and the faint mineral note that comes off marble that has been in the sun. The cathedral is to the west, the baptistry further west still, and the tower stands at the east end of the complex, where it was always intended to stand, doing what it was always intended to do, carrying 8 bells that ring for services in the cathedral below, in a position its builders never intended and could not correct. They started building on bad ground. They knew it was moving before the 3rd floor was finished. They stopped, not once but twice, for reasons that had nothing to do with engineering. And in stopping, they gave the ground time to do something that no medieval builder had the tools to calculate: the slow consolidation of saturated clay under sustained load that made the next phase of construction possible. The interruptions were accidents. The soil mechanics were unknown. The decision to keep building on a leaning foundation was, by any rational assessment, the wrong decision. And the tower has been standing for 850 years. Not because the builders were geniuses, not because the ground was good, because 2 wars interrupted a construction project at exactly the right moments, and the ground beneath it quietly did something no one asked it to do. And the men who returned after each interruption looked at what they had and kept building anyway. They were trying to build a straight tower. They built the most famous leaning one in history. And against everything that said it should have fallen, it is still there.